In areas that are prone to flooding during periods of heavy rainfall, installing an attenuation system can be an excellent solution. The Rainbox C+ geocellular stormwater management system from Dyker is the perfect choice for light and heavy-duty attenuation applications. With the proper planning and system design in place, the installation of a Rainbox C+ attenuation system can be achieved in 7 straightforward steps. Excavate the ground to suit the size of your planned attenuation tank. Follow the recommended installation depth and coverage instructions provided in the technical documentation. Allow extra room for safe working practices. Add an installation bed of 100 mm filler material, such as clean sand. For an attenuation system, adjustments should be made to the level of the fill to accommodate a sloping gradient of 0.5% to 1% down towards the outlet. Line the hole with a non-woven protection fleece first, followed by an impermeable membrane. Ensure they are large enough to fully cover the planned tank. Overlap cuts or joins by at least 0.5 meters to avoid material intrusion into the structure. Once the membranes have been installed, the Rainbox C+ crates can be removed from their pallets, assembled, and then laid in straight runs one layer at a time. Each Rainbox C+ unit consists of 4 major parts. Crate sections. Each crate is made up of 2 halves that connect together. Side plates, up to 4 per crate depending on the structure of the system. Sedimentation channel, made up of 4 inserts per crate. Connection clips, 2 for every side adjacent to another crate. Putting the crates together is a simple, straightforward process, as all of the connecting parts have been designed to easily clip together. It is highly recommended that the optional sedimentation inserts be installed in each Rainbox C+ crate along the inspectable run. 4 sedimentation inserts are required per crate, 2 in the top half and 2 in the bottom half. These inserts are easy to install, securely clipping into place with a gentle push, and require no extra parts. At each end of the sedimentation channel, the inserts will need to be trimmed down with an appropriate cutting tool to allow for the side plate connection. Once the sedimentation inserts have been fitted, if required, the 2 half-crate sections can be interlocked to form a single 800 by 800 by 330 mm unit. The interlocking is only possible if the top and bottom modules are positioned correctly to allow for unobstructed flow through the central channel. Each half crate features 20 struts, or legs, evenly distributed on either side of the central inspection channel. They utilize a spigot socket system to form a strong connection and ensure the correct alignment of the 2 sections. When constructed, the crates should be laid in straight runs, 1 layer at a time, to build up the planned attenuation tank. Make sure that all the crates are aligned properly so that the inspection channels all run in the same direction. Crates adjacent to each other on the same layer should be connected using the red clips provided to maintain the structure's cohesion over time. 2 clips per crate edge are sufficient to ensure a solid connection. When properly aligned, the 2 adjacent crates will create spaces along the join for the push-fit clips to be inserted and locked into place. Once the first layer of crates have been laid and connected together, all external facing sides of the tank should be closed off with Rainbox C+ side plates. These side plates are 800 by 330 mm in size and are designed to fit perfectly onto the crates with a series of built-in clips. They serve to further strengthen the mechanical resistance of the tank and prevent any deforming of the geotextile membrane. If the system's design calls for multiple layers of crates to be stacked on top of each other, small centering studs on the outer face of each half crate's base plate will help to facilitate the vertical alignment and joining of the crates. The studs are intentionally situated to only allow correctly aligned crates to be connected. If the top and bottom crates do not fit together, rotate the top crate until the centering studs interlock properly with the bottom crate's connection holes. When building up any additional layers, it is important to remember that the direction of the inspection channel must be kept consistent. The alignment studs and spigot socket strut connections should aid with this. To complete the attenuation tank construction, Add connection clips and side plates to all additional crate layers as necessary. Once the attenuation tank has been constructed, the inlet and outlet pipework connections can be prepared. Each Rainbox C+ side plate is equipped with a saw cutting matrix designed to suit our standard 110, 160, 200 and 250 mm pipes. The inlet and outlet holes can be cut out of the target side plates with a jigsaw, guided by the pre-molded concentric circles that match the required pipe size. While the side plates can be rotated to align the pipe holes to either the top or bottom of the crate, we recommend that inlet pipework should always be aligned to the top and outlet pipework to the bottom for best results. If you're planning to use an inspection camera as part of your system maintenance, however, your inlet pipe will need to be connected to the bottom of the tank to enable access. With the tank fully constructed and the pipework connections prepared, the next step of the installation process is to completely wrap the tank in the geotextile membrane layers. The impermeable membrane should be sealed with lapping and jointing techniques and then air tested for leaks. The protection fleece should have any joints overlapped by 0.5 meters to avoid any intrusion of materials. The next step of the installation is to connect the pipework. At the inlet and outlet locations, cut through both layers of wrap. Make sure any flaps of material fold outwards and don't get pushed inwards when connecting the pipes. The holes through the impermeable layer will need to be sealed around the pipe to prevent any leaks. This can be achieved by welding or taping a top hat connector over each hole in the membrane, allowing for a solid, watertight pipe connection. Pipework from the area that needs drainage relief should be connected to the tank's inlet hole at the highest point of the structure. Pipework draining to the discharge location should be connected to the outlet hole at the lowest point of the structure. Installing optional silt traps upstream of the inlet and downstream of the outlet is recommended to improve the long-term durability of the tank and give easier maintenance access. Depending on the tank's configuration, vent pipes may also be needed to regulate the internal pressure. Vents can open either into an inspection chamber annexed to the system or through specific chimneys. Additionally, a flow control device can be installed downstream of the outlet to better regulate the discharge of the stored water. However, this would require adding a chamber that can house one to the installation plan. Once the cellular system has been fully wrapped, it can be surrounded by a suitable backfill material. This should be installed in accordance with industry best practice for material choice and compaction. Typically 100 mm of clean sand or gravel backfill on all sides, built up and compacted in 300 mm layers should be sufficient. Recommendations will differ, however, depending on the loading application. Once the appropriate backfill has been added, any surface layers can then be relayed to fill in the excavated hole and complete the installation. Installing an attenuation tank can significantly increase the drainage capacity of the area by storing excess water during periods of heavy rainfall. The stored water is then allowed to slowly drain away to a suitable discharge point over time to avoid flooding. For more information about how to install the innovative new Rainbox C+ stormwater management system from Dyker, contact JDP today.